it's pretty awesome conference. It's always great to get back and speak at the Scale by the Bay. Good morning, everyone. Thanks so much, Pardis, for this introduction. And today we're going to be talking about some of the patterns, different techniques and ideas. And hopefully at the end of the talk, you will be quite savvy on understanding what is it, what's the difference, and many questions that I have usually they coming from this, like what's the difference, like what's this all about, and today we're going to talk about this. So I would like to start to talking a little bit about like why connectivity is important, and like why having clear and well-defined connectivity for the services it is important, and it's part of the every engineer agenda, I would say. So everything is easy when you have just like one service or one component or one application. This application does one particular thing. You're starting maybe with some sort of MVP, like some of the idea that you have. You start building this idea and build this as a beautiful piece of code that works and does exactly what needs. But during the time where you need to start moving these things to production, you need to think about some of the data responsibilities. And in many cases, those things can come with a price. You start building complexity in your application. You need to provide things around authorization, notification, maybe using like third-party service to do this, maybe providing the ways how your service will interact with other services and so far and so on. Your application is not that small anymore. It's already big. There's a lot of functionalities. There's a lot of maybe somehow even indirect communication between different components and between different services. At some point, you need to bring some of the external systems into play. Things getting really hectic. You don't already don't see light. You don't really understand what is going on there, and the management of these things, because you keep adding the code. And this is how we end up in a situation where that many people known as a kind of like monolithical application, where it's not easy to think about this, and it's not easy to what's the word I'm looking for? So it's not easy to reason about this microservice, or it's not a microservice, it's a monolithic service. Bunch of that code. You need to have a crazy mad scientist who will explain this to you, and specifically application, how the services communicate to each other. Things becoming not very easy. Not one person can explain this. And I think this reference to It's Always Sunny in Philadelphia is always great, explains like how when you're trying to explain how the services communicate, and the different APIs calling another API and so far and so on. So we'll try to make sense out of it by implementing some of the clear patterns of communicating of the system. And at the end of this presentation, I'll give you even a quick cheat sheet that explains or how your mental model should work. I work as a developer advocate at the Conk. At Conk, we are building solutions for cloud connectivity. I am speaking at the conferences. Since I'm a developer advocate, I'm trying to meet developers where they are, so we can talk about the things what they need to know, things what they need to build. You can find me in all these places. Twitter is probably the easiest place where you want to ask the questions. Also, I'm available on Telegram, and also I have a YouTube channel where I'm posting some of the videos and streams and talking about stuff. And the quick announcement for the people who've seen some of my talks in the past. Yeah, I was doing a lot of work around the Kafka, and this work will culminate in an upcoming book called Kafka in Action. I just got the call from Manning like yesterday that they told me that the book will go into print literally next week. So I'm super excited, and you can grab the code Kafka in Action 35 to get the book right now. So kafkainaction.org. Check this out. So we're going to be talking about the first place. We're going to start from explaining the concept of, probably many of developers already familiar with concept of proxy. It's one of the patterns that people can use in their application, but also it's an infrastructural pattern that allows you to put something in front of your application to do something. In many cases, back in the day, we put the proxy in front of our application. The proxy might be doing something like caching of certain resources, and this proxy will be responsible for routing traffic to your application. And the more and more we start hearing the term a gateway more often, and what is it, and like how it's different from proxy. So in this like first part where I'm going to talk about gateway, we're going to focus on API gateway concept. One of the things that I'm mentioning here, the sideline, during the simulation, new capabilities will be provided at no cost. Also, like write down in the comments, or like if you're watching this live, or like in Discord, like if you get the reference. But the reference would be explained in a few slides. So just a quick note. All right. So what's the API gateway, anyways, right? So we know that's pretty a pretty familiar concept where the people might say, okay, so that's maybe just clarified proxy or whatnot. So API gateway pattern describes somehow additional hub in the network where your clients communicate through some service. In this case, it behaves as a kind of intermediate thing. That's pretty much it. You can say that's what we have here. That's what we used to know as a proxy and gateway. What's the difference? And I feel like this explanation, it's kind of a little bit of simplification of this concept. Sometimes it can be called proxy, sometimes it's called load balancer. But I think the API gateway, it's not maybe a particular product or project. I think it's just like a pattern. And I would like to break down I think there would be like 3 examples where we can use this API gateway. And the first pattern that I want to start with is the service connectivity, because this pattern essentially, like, it is how everyone is using API gateways. It's a kind of good old day proxy. So in this use case, it's about providing or like enforcing some of the policies that your application needs to employ. On the previous slide, so in this slide, you can see here, this part is super simple. So our client calls, this is our, say, client application. So we need to call this this API, but we're not calling this directly. We're calling this through this proxy, so through this guy. And since now traffic control belongs to this intermediary, this like API gateway, we can do a bunch of cool things with this. Specifically, let me get back here. So specifically, there's a lot of interesting things can be done. Many of people offload some of the work around the traffic management to API gateway, specifically providing the ways how client can communicate to underlying service through HTTPS, for example. In this case, developers of this like API that we need to call, they don't need to even worry about this and implementing this as a part of the software or a part of the system. In this case, the API gateway will handle this and providing this out of the box. So these pieces of functionality will be available. Next thing that you can also implement some more advanced like traffic policies, like things like rate limiting. Your API might be calling some underlying systems that you really don't know, and we talk about this also as well. Those calls can be very expensive. When you're calling those systems, you don't want to overwhelm this by incoming requests. And another example, which will be correlated to next pattern of using the API gateway, the the API as a product. You might want to restrict or providing different level of service to your consumers, to your application consumers. There might be some customers that get access to your API for free. So in this case, you need to provide certain level of service for them, maybe a limited number of requests per, I don't know, per minute, per hour, per day, per month, per week, per month, or maybe as they provide you, if you more like a premium customer, they provide you more, faster bandwidth. So you need to have this ability to configure this. And of course, it can be built part of the service, but why? Where each and every service needs to have this piece of functionality. And it seems to be redundant to build these like beefy services for every time. Remember, like microservices is not about size, but it's about a piece of functionality that they need to implement. And this piece of functionality needs to be somehow like solve this particular task, but not overwhelm this by infrastructure. Infrastructure needs to be handled by underlying components. Another familiar pattern many of you might did in the past with using like proxy servers is to log everything and providing some additional observability points, right? So all requests that come into from your client can be logged and captured somewhere, and after that analyzed, and you'll have some additional data points for your application. So let me illustrate the concept of this by showing the picture of Jean-Luc Picard, captain of Enterprise from the Next Generation. And if you would remember this picture for a moment, and that's your basic service. You have a service that does one particular thing. However, a lot of things that comes into play with this infrastructural task, I would say, needs to be implemented either as a part of application somehow, or there's a big question like how to implement this. And of course, many languages and many frameworks providing this piece of functionality, and it can easily built into your application. But in many cases these days, we don't want to enforce developers to particular language or to particular framework. We want to give them a choice, and that's why the question comes into play: like, who will implement all these things, right? So, is it the part of the developers need to implement, the part of the framework, and after that, this stuff needs to be supported? What about things that you support this in one language, and do you have a parity of the same framework in another language? Like you have a system that developed in Java, system that developed in Go. Like, do you have the same frameworks? But with offloading these pieces of functionality to something like API gateway that can provide you or augment you with some additional pieces of functionality, that's what you get. In case of like particular example, the way how the Conk solves this problem, Conk is the API gateway, and it serves this by providing the set of plugins that will enable those pieces of functionality, where your client will just simply will be hitting this API, and infrastructure will be provided in order to protect your API. Which brings us to the second point, like why you want to do this on the first place. So the service connectivity can be can serve two sides. One side, if you're building an application and this application would be used internally, and this is one use case. And the second case where your application will be served as externally. But in both cases, your application will represent a API as a product. So to develop this, you're developing something that other people and users will be used. It can be external users that come for your company and for the data in your company. And it can be some internal. So you building something, you're building authorization service, or you're building service that will be providing the data like an internal fulfillment service. So there's different departments might be using this fulfillment service. So it can be internal and can be external. And so in this case, when the API is offered as a product, API gateway can encapsulate the common requirements that I already kind of like touched a little bit. So those requirements can be enforced and implemented with the things that like plugins that enable different pieces of functionality. And this thing can be standardized. So when your organization has a certain standards around what services needs to be used in order to authorize incoming users and authenticate with different different rules, how implement, I don't know, things around service level agreement and monetization of those APIs, those things can be uploaded from your application code into API gateway code. Another important thing is that it when the API gateway serve a need of building API as a product, it also allows you to provide certain level of support for some legacy APIs. Your underlying infrastructure, your underlying, this part, where's my pen? So this part, this underlying part can evolve independently from client part. And API gateway will take a responsibility of supporting a, say, legacy client if your API changed. So there's ability in the API gateway side of things provide certain like rules of transforming API calls that old client will issue in order that new API to support. So that's one of the probably one of the biggest use cases and one of the biggest the selling point why API gateway serve the purpose. So it's not dumb proxy anymore. It's not only just like a passing through request to underlying service, upstream service, and a log this somewhere like, oh yeah, that's client access. So now there's more knowledge, there's more routing. So based on some sort of like a token that comes from the client, we can figure out, oh, let's roll out the new features. We're providing some sort of like A/B testing scenario or like canary deployment, and based on certain criteria or certain I don't know, percentage of requests, this API gateway will route to particular service or particular version of the service if you want. Now, so since API gateway used in this pattern as a product as an API, so developing API and throw them at people, it's one thing, but you need to support those people. And by support, I mean, you need to provide documentation that explains this API. You need to provide the ways how this API can be tested. Or maybe there's some cases where if you say do API as a product, but for internal needs, your backend and your front-end people might agree about API, but their timelines on delivering certain features are not in line. So developers on the front end need to continue to build their awesome mobile application or some of the website, but maybe API will not be ready. The implementation of API will not be ready. So in this case, API gateway can be used to say mock this API and provide the ways how your one team can be doing the things while another team will be providing implementation. After that, when they're ready, you just flip the switch, and all of a sudden, your clients start using this mobile application, say, start talking to real backend. So this is where this API gateway becomes a one of the connects all the pieces of this puzzle. Like this is one thing that controls everything. So, and it becomes more than just like a dumb proxy. It becomes even more than API gateway for your request transformation. It becomes a tool and a platform that supports your API management lifecycle. So management of API, users and client application and traffic and runtime requires, you know, I don't want to like oversell this, but like it's a bigger part of the strategy of the organization, and the components around designing and the building APIs and it's one thing, and developers like to focus on this side of things, but there's some other things that supporting thing, like monitoring, providing the way, understanding how this API is used. It's also part of this API management platform, and API gateway become a central piece that connects multiple different phases of designing APIs. Maybe there's a tool that there's a tool that allows to design this open API spec that is a more or less common standard of defining APIs, and use this spec from point of designing to creating a mock service, so the systems can start be tested. Once this design phase is done, we're going into the phase where all these day two responsibilities needs to be handled. For example, onboarding developers, external developers to the API. So in this case, documentation needs to be in place. Things around like a testable example, so that people can start using this API immediately, enabling developers of API to use this. So, like, you see how we started this? We started this with the very small use case where we have a proxy in between our client and service. We gradually go into the point where we offloaded some of the functionality that comes into particular like in the gateway side of things, and after that we moved the gateway in the center of our API management strategy, and this is how the different platforms like to position themselves, and the things that I just talked about is also available in Conk, which is, you know, can be used as a simple proxy. It can be used as a more advanced like API gateway, providing these building blocks to enable different features through the plugins. And third pieces, it also includes some of the things for API governance and management, and providing the monitoring capabilities. Hopefully by this point you will get a pretty good idea of what the hell is this API gateway now. And now it's time to go to another pattern. It's another architecture pattern. And with the many conversations that I have with people around this, many resources that like to describe like API gateway, it is something that routes traffic from north to south and gateway from east to west. What the hell does this even mean, right? So where is the south? Like for me, like I know that in America, people generally very good on figuring out like, okay, so that's, you need to go like a few blocks to north, you need to go to a few blocks to south. I don't understand this. I don't have a compass in my brain. So that's why the term, when the people talking about this traffic direction, it's not very, that's not very sets very well with me. However, I understand usually by north-south traffic, people mean like inside and outside data center, and north to east, west to east or east to west, it's the inside the data center. But it is not the case, because I just showed you that API gateway can be used internally. So in this case, it also can run the traffic inside the data center, and can run the traffic externally from whatever north to south. So that's why I don't personally like to use this this analogy. And this is where which brings us to mesh, which brings us to mesh idea, because like people say, yeah, like it's routes from east to west. Like, what does it even mean? Now, when we talk about mesh, we are having multiple different applications. So inside our data center, let's talk about this here for now. So inside our data center, inside our piece of functionality, now we have different services, and those services can communicate to each other through gateway. You know, you see the Borgs, they're already augmented. So those services might have a gateway in front of them to some sort of gateway that provides this piece of functionality around authorization identification, maybe even traffic encryption, and then so far and so on. Those things are already exist, and we need to, you know, have some centralized management. And the way how it was centralized and managed in a world of Borg, it was just a Borg cube. And in this case, there should be something that would be controlling these things. And those things can be deployed. Those Borg cubes can come from different galaxies. In this case, your application can be deployed not in one data center. It's now decentralized deployment. And the way how everything was controlled, it's through Borg Queen. In our case, in more, you know, human sense, the mesh will include two components. So our Borg, our service, this guy, that's going to be our data plane. That's where we're going to be data plane. That's something that will do the work. Will route the traffic, providing some of the traffic shaping capabilities, providing different features. And this one, it's going to be our control plane. So, and control plane will be sending the configuration information that will store configuration in one place, and after that it will ship this configuration to the data plane. With this similar idea in mind, with Borg in mind, those Borg bots can be relatively independent. So in this case, when the connection to control plane will be lost, they still will continue to perform their task. Same thing with the service mesh. It usually includes two components. Control plane is a centralized thing that will be providing some of the management capabilities, and data plane is where something that will deploy it next to your application. Think about this data plane as a kind of like a small proxy and small gateway sitting next to your application to reduce the latency. And after that, it provides a set of capabilities similar to what I just described in the previous slides. And to infinity and beyond, we can deploy these meshes across data center and provide a unified communication between applications. So in this case, application developers start thinking not in terms of data centers, not in terms of servers, not in terms of locations, but in terms of like meshes. And those meshes can be geographically distributed and not only deployed in systems that support this sidecar model of deployment. Like Kubernetes, we have a pod and we have an extra pod that will be performing this traffic. In some systems, you just run separate process next to your application, but it requires some of the kind of like automation and some of the tooling around this. Now, so with what I said, so let me quickly bring in this idea to home by demonstrating this, how your thought process should go about the API gateway. So you have like use case where you're building a service, and this service needs to be offered either as API as a product, so there will be some external consumers. So that's why we're going, if it's going to be used by external consumers, you need to make a simple decision. If it's be consumed internally, you will build a gateway in front of the service, in front of this API. In the case of external, you will have a API gateway that will be sitting in the edge. They might have a different requirements in terms of how the services need to communicate internally. For example, external API consumers, they not be able to get internal authorization system to get access to the system. So maybe there would be some third party that also would be deployed close to the edge. And if it's internal, it can be used with the internal API gateway, and different policies will be enforced. So that's where you're going from perspective of like providing a service that will be used by someone as another service. Let's take another route. Let's take another example. So you building this. Let me erase this, guys. Or I should use a different marker. So now you're building something that will be used not anyone else in the system. You're building one complex system, but it would be another puzzle of your microservice architecture. So in this case, you're not offering the service as your as a product. So you're not like per se, no one will call it except your application. So if the system where you deploy supports so-called like a sidecar deployment, so you can embed small proxy process next to your application, systems like Kubernetes, or systems where you can simply run, two processes, your application process and your sidecar process. So in this case, there would be service mesh where you can definitely benefit for your use case. And the next thing that you need to decide, okay, am I doing this with existing mesh? Do I need to care about multi-regional or multi-zone deployment? It's as a part of the bigger mesh, or it's just like simple? If it's a simple, so you just like have something like creating new mesh. Or if it's something like bigger, in this case, the existing mesh, we can join or add another sub mesh, like a smaller mesh, into the bigger mesh. But again, like you still can use internal gateway, an internal API gateway for use cases where you don't have a luxury of deploying these sidecars to your application. Maybe it's not feasible from perspective of your processes, not super easy to deploy, or maybe there's some of the other limitations, but you always will be able to use this internal API gateway to do the thing. So essentially, two things that you probably can get out of here. The API gateway admits external traffic, and by external, it can be edge. So this really external, or someone that would be outside of the boundary of your organization. So we're bringing traffic from outside. And mesh, service mesh, connects your application. So it allows your system, allows the microservices to communicate more efficiently. You can untangle the communication between the services through different traffic policies, and providing the destination and the source of these services more explicit. So with this, I hope you got the idea. If not, I will be available for some enhanced interrogation and for Q&A. But for this, my name is Viktor Gamov, and as always, have a nice day.